Hey, I'm Chris Ralph, the professional prospector, and I'm doing a series on mineral identification. I'm basically taking the mineralogy class that I took in college that was about years ago, and I'm condensing it down to make it something that's easily digestible, that anybody can understand. And I'm teaching you the clues that you need to know to find and then identify minerals. Now, I went through the clues and some of the introduction in the first two parts of this three-part series, and in this third part we're going to take a closer look at minerals that you would be interested in, from gold and silver and different kinds of ores, even ores of unusual metals like molybdenum or chromium or something like that. We're going to take a look at a bunch of different things, at gemstones, and we're just going to have a great time. And then I'm going to talk to you about taking all the information that I've talked to you about in this series and integrating it and putting it all together so that you can go out and find and identify your own minerals. When you find something in the field, you can say, oh, yeah, that's a piece of quartz, or that's a piece of mica, or that's a piece of gold. Anyway, I think you'll really enjoy it, so come on with me. We're going to do the third part of this three-part series, and I think after going through this, if you haven't already gone through the first two, you're going to want to go back and see them. So let's get started. Well, let's get started with part 3 of our mineral identification series. I hope you found it helpful. We've been going over the clues that you need to help identify minerals. So one of the things I want to talk about is that field identification of minerals is not always easy. You know, when you're out there in the field looking at stuff, even if you're an experienced geologist, you know, some minerals can be harder to identify than you might expect. One of the things that's really important is that weathering can make minerals really hard to identify. Weathering can change the hardness, change the color, obscure or even change the luster. And when you change all the clues that tell you what a mineral is, well, that's going to be pretty hard. Minerals are often converted in the weathering process to clay, and like I say, that changes their hardness. They can even be converted to other minerals. I showed you earlier a chunk of pyrite that had been converted by weathering into iron oxides, like rust. And it'd been converted just by a natural process of weathering. So, you know, identification of minerals isn't always easy. Now, I've mentioned a number of times that colors can vary quite a bit. You can have one mineral, but it can come in many different colors. Lumpy or broken pieces of minerals may not show their crystal shape very well. Minerals from the same family, like garnets, can be tough to separate one kind of garnet from another, or one kind of mica from another, one kind of feldspar from another. Field identification is possible in most cases, but it isn't always super easy. And what you know, like I say, makes the difference, and that's why we're doing this course. Now, we've gone over the clues, the identifying characteristics a little bit, but I'll just do a little quick review here. The crystal shape, mineral hardness, mineral density, cleavage. Cleavage is that minerals, a number of them, tend to break along certain planes, and those planes can be very characteristic to help you identify what a mineral is. Now, mineral color, you know, I've said is the weakest of all these clues. It's the most easily visible, and we're going to talk a little bit about streak testing in just a second, because I haven't gone over that. And luster, whether, you know, it has a metallic luster or glassy luster, pearly, adamantine, magnetism, and then chemical tests, of course. There's some you can do in the field, but, you know, the most thorough chemical tests are done in a laboratory by a chemical company that has all the equipment. And unfortunately, the full thorough chemical test can be pretty expensive. So let's do a quick review of this. I have talked some about crystal shape and how characteristic that is. And I just wanted to show you, like for quartz, you know, our upper left-hand side here is a drawing of the classic the shape of a quartz crystal. And I've got a number of examples here, and you can see examples from all over the world, some very different examples,
all show this same characteristic crystal shape. And one of the things that's about quartz crystals, unless they've been polished or done other things to them, as they come out of the ground, you'll see this on the drawing on the upper left. The M faces have lines going across them. There's a series of growth lines, basically, is what those are. As the crystal grows vertically upward, you get these lines on what are the M faces of the crystal. And on all these crystals that I've shown you here, you can see that. Now in the picture, you can only see it clearly on the lower right-hand one. You can see the growth striations that go across the crystal. But in real life, you can hold quartz crystals if they're of any size, and you can see these, and it helps identify the quartz crystal. Here's a shape, a corundum, which is ruby or sapphire. You can see it's a hexagonal shape. When you look down the crystal, you get this six-sided shape if you get a good crystal shape, and then usually a fairly flat termination on either end of the crystal. But again, these crystal shapes can tell you a lot. Hardness, of course, each mineral has its own hardness, and you can test for that in the field. I have here my little field test. I kind of showed you this on one of the other videos, but here's a close-up of it, and it's labeled what each mineral is. You can see on the lid, it shows you what things are, and scratching one mineral with another can tell you the hardness of the mineral you're trying to identify, and that can give you some real strong clues. And then this thing includes a little hand lens for seeing crystal shape in crystals that are small, a magnet, some streak plates, and like I said, we're going to talk about streak plates in just a second. The streak plates basically is an idea that you can grind a mineral on a plate and produce a powder, and that way for minerals that are really dark in color, you can kind of tell whether it's really dark brown or really dark green, really dark blue, things like that, and that can be helpful. I talked about cleavage or fracture, and here's some more pictures that help show you this. The green mineral on the upper left is actually the same mineral as the clear mineral on the lower left. Both of these are calcite, and you can see that the angles that the mineral tends to break at when you have a cleavage, that can be characteristic. And so you see in the green the angle of the breakage, and then in the low crystal on the lower left is the same angle of breakage, and that tells you a lot about the mineral. On the right hand side, you see the kind of cubic one with the breakage. That's actually the mineral halite, which is table salt. You could take this, purify it, and grind it all up, and it would be table salt. And it has a cubic breakage. And then on the lower right, you have muscovite mica, which we've talked a little bit about mica and how it tends to break into sheets. Now I mentioned a streak, and here's a really dark mineral, and someone has given it a streak across the plate, and you see the powder there is kind of a brown color. And this is what you get out of streaking minerals like this. You can tell, and instead of just, well, it's black or really dark, looking at the powder can give you a clue as to what the actual color is. So what is a mineral? A mineral is a substance that meets the following 5 criteria. It must be naturally occurring, meaning, things that are made by man are not really minerals. So tungsten carbide, which is a hard material, lately they've been using it for wedding rings. My son's wedding ring is made out of tungsten carbide. It's not naturally occurring. It's a man-made product, so it's not a mineral. Inorganic, so something like coal, which is a product of trees and that sort of thing compressed down. Coal is not a mineral. It must be solid, so water, like the ocean, isn't a mineral. It has a definite chemical composition. It can't just be a mixture of things. It has to have some kind of fixed chemistry, and then an ordered internal structure, which means it has to be crystalline. So something like opal is not a mineral, even though it comes out of the ground, because opal is actually a gel. It's kind of like Jello, only made out of inorganic chemicals instead of proteins, which is what real Jello is made out of. So let's look at some common minerals. We're going to start off with quartz. And quartz, actually, it's silicon dioxide, or SiO2, so 1 silicon and 2 oxygens, and it is probably the most common element on the Earth's surface, because it's made of the 2 most common elements in the Earth's crust. So silicon and oxygen are the 2 most common elements in the crust of the Earth. You put them together and you get quartz. So here's some examples that look wildly different. You can see the quartz crystals that look like I had showed you just earlier, and if you look really closely on the crystal in the back of the crystals, you can see the growth lines that I mentioned earlier. The purple crystals are amethyst, and amethyst is a mineral, a variety of quartz. It's purple colored quartz. The lower right is a piece of vein quartz, which is the kind of vein material that gold occurs in. But I will tell you that there's a whole lot more vein quartz than there is gold-bearing vein quartz, or vein quartz with significant amounts of gold in it. There's just a lot more quartz because it's, like I say, a very, very common mineral. Now, the lower left looks like a big chunk of wood. Well, it's a big chunk of petrified wood from Arizona. And it's a piece of wood that's been mineralized, and over a long period of time of being buried, the wood of the log has been replaced by quartz. And that's what petrified wood is. Now here's some more examples of quartz. You can see the upper left is gold-bearing quartz. Now I said gold-bearing quartz is a lot less common than just not gold-bearing quartz, but this is an example of what it looks like with a lot of gold shot through it. Then below is rose quartz. This is a pink quartz. And then on the upper right is what's called a Japan Law twin. This is basically 2 quartz crystals that grow together at right angles. And this is actually not just a random thing where 2 crystals just happen to grow together at this angle. This is a standard thing that occurs fairly regular when the atoms of the quartz crystal start growing in certain directions, and in the right conditions they grow at these right angled crystals. And then the lower right is what's called fire agate. That's my favorite form of quartz because it's just a beautiful gemstone, and it's rare and only occurs in a few places, but it's just really, really beautiful. Next we have gold, and the characteristic things of gold are its metallic luster. Of course, it looks like a metal, and then its super high density. Now you would say the yellow color is, and yes, that's true. However, there are shades of gold that have naturally alloyed silver in them, and so you can get gold all the way from the normal bright yellow that you're used to, all the way through pale colors. The one in the upper right here is kind of pale a little bit, but there's ones a lot paler than that. I could have put an example here where it's literally almost just silver color. And in fact, there are a few districts. There's an Oro Blanco district in Arizona that's, Oro Blanco is Spanish for white gold. So it does occur in various shades from yellow to silvery colored, depending on how much silver is alloyed with the gold. There's actually a separate mineral name for the really pale stuff called electrum. And then pyrite, of course, if the crystal is right, you can see the cube shape as in the one on the upper left. The one on the right is cubic also. It's just that the picture that I've got here doesn't really show that as well. If you were able to hold this specimen in your hand, you could see that the crystals were cubic shaped. And then the one on the lower left, the crystals are really small. it would be harder to identify the cubes in that. But I think some of them at least you could identify it if you were able to look at it closely in person. Now here's copper ore, Chalcopyrite. This is probably the most important ore of copper. And it looks gold in color and metallic, but it grows in certain crystal shapes and is readily identified. It's a little more brassy and yellow colored than pyrite is normally. Here's some more copper ores. These are oxidized copper ores. This is what happens when you take air and water and have it act over a long period of time on things like the chalcopyrite I just showed you. You eventually produce things like this, which is the green is malachite and the blue is azurite. I mentioned metallic silver, and of course silver by itself sometimes occurs as a mineral, and you can see these strange and weird shapes. I've done a video on silver and silver ores, but this is just a quick look at some examples of metallic silver. Silver ores themselves, you can take a look at these examples. They tend to be dark colored and often sooty kind of looking or earthy. But the thing about that is that there are a lot of other things that tend to be dark or sooty. So, just because of those two doesn't prove that it's a silver ore. You'll need other clues, and this gets back to what I was talking about, where you need a series of clues to help you identify your rocks and minerals. Here's platinum. Again, it's metallic and it's silver colored, but this is much more dense than silver. So if you had a chunk of platinum and a chunk of silver in hand, they're both about the same size, the platinum would be almost twice as heavy as the silver. So platinum is actually a little more dense even than gold. Now, speaking of density, here's a lead ore, a very famous lead ore, Galena. It's probably the source of almost all newly mined lead comes from Galena, and it has a cubic cleavage and a cubic crystal growth face. So both the growth of the undisturbed crystals, and if you break them, they both break into a cubic sort of arrangement. It has a high density, and this lead color, this gray color, is kind of characteristic. When you add those all together, that's pretty sure definition, or that will guide you to identify a mineral as Galena. Let's take a look at some unusual ores. On the left, we have nickel ores. The garnierite, the green, is an oxidized nickel ore. There are places where this is mined. There's an area in Oregon that was mined for this mineral and produced nickel. And then the lower left is a sulfide, a nickel-bearing sulfur mineral. You can see the kind of metallic luster that it has. And then on the right are cobalt ores. The upper right is a pink-colored ore of cobalt that comes from Nevada. And then on the lower right is a metallic sulfide type ore, and this comes from Canada. Here's some chrome and molybdenum ores. On the left is a dark colored mineral, that's chromite. It's heavy and it comes in a certain area, certain type of geologic environment, but it's the chief ore of chromium that's used for like chrome plated bumpers, that sort of thing. And then on the lower left is another mineral. This is a lead and chromium mineral. That's a kind of an unusual thing, but it makes for some interesting specimens. On the right, we have molybdenite, and this is the main ore of molybdenum metal that's used as a special strengthener in some types of steels, that sort of thing. But it's a valuable ore and is mined in a number of places across the world. Here's some manganese ores. And manganese is also another thing that gets added to certain steels to strengthen it. And here you can see some dark and sometimes almost earthy kind of color that it goes with a lot of manganese ores. And then iron ores. Here's magnetite and hematite. And on the right is the magnetite, and on the left is the hematite. And it doesn't always grow in this kind of lumpy, the hematite doesn't grow in this lumpy formation. It doesn't always look that way, but it makes for an interesting specimen when it does. But these are the ores, the chief ores of iron. Now, arsenopyrite is an arsenic-rich pyrite. Instead of being the normal yellow color that you're used to with pyrite, this is usually a much more silvery kind of color due to the high arsenic content. It is commonly associated with gold. The piece on the left there is a little chunk I picked up off of a mine dump in Western Australia, was showing to my companions there with me. And then there's another specimen here on the right. But I've seen some really nice arsenopyrite and gold specimens from the mother lode country of California too. Feldspars are a common rock-forming mineral. You can see some examples here. Different colors, grays, buff and pink colors are pretty common. And then this green one in the lower, the kind of blue-green in the lower left is amazonite, and it makes for some nice mineral specimens. It's not a very common type of feldspar, but there's lots of different feldspar minerals. And then the mica is also another family of minerals. In general, a lot of the lighter colored micas are from the muscovite family. The darker colors, a lot of them are biotite, but there are a lot of other micas. This lavender color in the lower right is lepidolite and is an important ore of lithium. Calcite is a rock-forming mineral that it basically is the main mineral of limestone. And you can see the green and then the doubly refractive crystal on the lower right. I've shown you those already, but these are examples of calcite, which is the main mineral that forms the rock limestone. Fluorite is another important ore. It's actually mined for its fluorine content. Its calcium fluoride is the elements that make up fluorite, and it comes in just a wide variety of colors and often makes some really beautiful crystals. And you can see these examples here. It's the mineral that goes when they put the fluoride in your toothpaste. This is what it comes from. Garnets is another family of gemstones and minerals that used in mineral in a lot of rocks. And you can see an example here that's near black. I have other examples that are kind of orangey brown. And then in the lower right, there's a little bit of a green colored. Garnet comes in a wide variety of colors. Here's an example of beryl and emerald. You can see the blue-green is kind of aquamarine. The pink is morganite. The yellow version of it is called helidor. And then there's a raspberry red version of it that comes from Utah. This is all the same mineral. It's called beryl. In the green form, it's called emerald. Of course, diamonds come in a wide variety of shapes and sizes. Generally, there's a diamond shape that you can see best in the lower left-hand side. It occurs in a rock called kimberlite, but it occurs in other rocks as well sometimes. The corundum family, I showed you at the beginning, rubies and sapphires. Here's some examples of really pretty colored ruby and sapphire. It has a characteristic hexagonal shape when you can see the shape. Some, like the upper right, those are natural pieces. It's hard to see the hexagonal shape on those. They're just kind of lumpy, rounded types of mineral occurrences. Tourmaline is another famous gemstone. It's been mined in Southern California and up in the northeast part of the country, in Maine and some of the northeastern states. But it's mined also in Brazil and a lot of other places around the world. Topaz is another famous gemstone, well known, and here's some beautiful crystal examples of it. And then turquoise. one of my favorites. I have some turquoise mines here in the state of Nevada. These are some different examples of turquoise, which is a really beautiful mineral. Now we've looked at some minerals, and let's talk about putting all our clues together, because that's the skill that you use to identify minerals. And like I say, identifying minerals isn't always easy. You need a number of clues to help you solve the puzzle of what this mineral is that you're looking at. And all the clues together combine to give you the information you needed. I told you in the beginning, it's kind of like the old game Wheel of Fortune that they have on the TV, where there's a phrase and then the contestants guess different letters, and eventually letters will appear and fill in the blanks, and eventually it becomes pretty obvious what the phrase or saying or whatever that people are trying to guess. And that's kind of like minerals. You figure out the hardness, you see the color, you look at the crystal shape, you know the association of where the mineral came from. You put these things, different ones all together. Cleavage, there's a cleavage, and then that will fill in all the blanks, and eventually you'll be able to guess what mineral it is. Now, don't get frustrated if you find it difficult. Basic mineralogy is a full semester college class. It's, when I took it so many years ago, it was a whole semester, and they talked about all different subjects. And of course, they covered more material because they had a lot more time than I've covered here in this just short introduction. But you've had a basically 1 hour condensation of a 50-hour college course. So I couldn't cover everything. But get reference books and practice. That's the thing. Practice makes perfect, and it's a skill, and just like any other skill, if you practice it, you'll learn to get better. Now, I've recommended various books, and I'm going to show you one in a second here, but there's a book called Dana's Textbook of Mineralogy. It's an old book from actually originally written in the 1800s, but still a lot of really valid, good information. It's not like the science has changed radically since then. And common minerals are still common minerals. And so you can actually search for this, use Google for Dana's Textbook of Mineralogy, and if you look on the thing there, you can find it's a free PDF file, and you can download it, and it has drawings. It's old, so it doesn't have color pictures, but it has drawings and that kind of stuff. And of course, if you do it right, the price is free. So hard to complain about free. Now, let's give you an example of solving a mineral identification puzzle. I actually posted this on my community forum there on YouTube, and this is the thing, and I had people guess, and there were some people that guessed correctly. Now, I'm looking at the clues that I can see in this picture and that I happen to know. The clues, first is that there's this unusual crystal shape. Note that the faces are triangles, and it's a crystal shape that has only 4 faces. The 4 faces come together to make a full 3-dimensional shape, and it's 4 triangles on the surface of this crystal. It's much easier to see that in person than it is in this photograph, but you can still see the triangular crystal shapes. So it's a tetrahedron, which is an unusual crystal shape, but those shapes do exist. It has metallic luster. It was found at a mine that's known for producing copper with some silver. And that clue, those 3 clues, the tetrahedron shape, metallic luster, found at a mine known for copper with some silver, it's tetrahedrite, which is a silver antimony mineral that, like I say, often contains significant amounts of silver. That's the kind of thing that you do to identify a mineral. Now here's one, a sample that I picked up in the spring of 2019, and I was really pleased because it shows us a mineral that's kind of unusual. But there's a number of different minerals here you can see, and I've kind of drawn numbers and put arrows to them so you can see what I'm talking about. Now the first one up at the top there, it's colorless, has a 7 hardness, I actually could see in the hand specimen with a loupe, I could see those horizontal growth lines along the length of the crystal that I've mentioned a couple of times already for quartz. And so that characteristic crystal shape and the growth lines, it pretty much identifies this as being quartz. Number 2, this is kind of an orange-brown. You can see actually the bulk of this mineral specimen is that orange-brown stuff. And I looked at that, and on some of the other parts of the specimen, you can see that it has a dodecahedral, which is a kind of a spherical crystal shape. It has a greater than average density. In fact, if you pick up this whole piece, you'll see it's much heavier than you might have expected it to be. And so greater than average density, and the orange-brown color, and the crystal shape, this is garnet. Okay, this is a variety of the garnet family. Number 3, you can see labeled there. There's just a couple of these things in there growing. This is a dark green colored crystal. You know, in this picture, it's hard to see. They look kind of almost blackish to dark green, but in real life, in a hand specimen, you would see real quick, even without any kind of streak test, that this is dark green color. So dark green, a long monoclinic crystal, so that's the crystal shape. It has a 6+ hardness, and although I didn't test the pieces in the picture there, I tested some other pieces on this hand specimen, and it is epidote, which is a mineral that commonly occurs with garnet. So it's a mineral association type of thing where you see garnet. It's not unusual to see epidote. And then the number 4 designated, this is a dark silver metallic. In the picture, it looks dark to almost black, but if you're looking at it in a hand specimen, it's clearly dark silver colored. It has a really strong single cleavage and a super soft hardness. I mean, it's super soft, and it is molybdenite, which is the ore of molybdenum, which is actually why I picked up this specimen, because it's molybdenum ore. So that just gives you a few examples of how I look at things and identify things and figure out what minerals are, and that's what I want you to be able to do. So after you've had this introduction, get yourself a book like this. Simon & Schuster's Rocks and Minerals is a good one. It's the one I use, but there's a lot of them out there, and they're all pretty good. They have color pictures, which is the one thing you won't get from Dana's textbook of mineralogy, but it does have the things that tell you, what different hardnesses minerals are, and the crystal shapes, and different other examples. And you can take a handbook like this with you in the field. You can throw it in your backpack, and once you get out to some place that you're looking around, it can help you identify things. So I hope you've enjoyed this course, because there are there are thousands of different kinds of minerals, and books like this will help guide you. And I hope that you'll get into being able to identify minerals, and that you'll use a handbook like this, and you'll get out in the field and use your lens to test and maybe hardness tests and that sort of thing, and you'll learn the skill of identifying minerals. It takes time, but you can do this.
So that's my series on identifying minerals. I hope you've enjoyed it. I hope you've found it useful and helpful. I hope that when you go out in the field next time and you see an interesting mineral or something, that you'll have the skills to be able to look at it, do some tests, figure out the puzzle of what that mineral is. Now, I'm totally open to questions. If you watch this series and you have some questions and you want me to give you some information, be sure and let me know in the comments, because one of the unique things that I do is I answer my comments. And so anyway, if you're interested in maybe seeing other videos, like I could do one on petrology, which is the study of rocks, identifying rocks. We've identified minerals. Now you may want to identify different kinds of rocks. If you're interested in that, let me know. But there's a lot to the skill of being able to find minerals in addition to just identifying them. And I wrote a whole book about prospecting, mostly for gold, but it talks about silver and platinum and even gemstones a little bit. And it's called Fistful of Gold, and it'll tell you what you need to know to be a better prospector. I'm going to tell you a little bit more about my book right now. So let me tell you a little bit more about my book. It's called Fistful of Gold, and I wrote it because I want you to be able to go out and find for yourself Fistful of Gold. And you can see that it's an encyclopedia with all kinds of information, pictures, and that sort of thing. It's not in color, but color would have cost me a lot more to have printed, and so the book would have cost a lot more. It's for sale on Amazon, and you can pick it up. I'll put a link in the description below. I also serve as the editor for a prospecting magazine. It's ICMJ's Prospecting and Mining Journal. And honestly, you should check that out. We got stories and information, legal stuff, everything you know to increase your skills as a prospector. I write articles in this every month, and a lot of other very experienced prospectors contribute to the magazine as well. So check the magazine out. Also, I have a website, and the website is at NevadaOutbackGems.com. I'll put a link for it in the description below, but there's gobs of information there that you will find useful in your prospecting efforts. Finally, I want to say that I really appreciate your comments and thoughts, and even positive criticism. Don't come on there and just toss out insults, because I'll just delete your comments. But if you've got helpful things to say and questions to ask, do write and put those in the comments, because I answer my comments to people, and you'll hear from me in responding to you. So if you've enjoyed this video and you like what you see and you're interested in finding out more, well then sign up, subscribe, and hit the notification bell so they'll let you know when I post new videos. And like it and share it if again you see stuff that you really are excited about. And I'll be coming out with lots more new videos, and so we'll see you again real soon.